Hey everybody, I want to put a special thanks out there to those people that have left good, positive, helpful comments out there for the community. It's really good to see people out there leaving positive, useful comments that really are just a pleasure to read. So thank you to those people. Thank you very much. It's great to see it. Very good. I don't know how long today's video is going to be. I've got lots of stuff to say, but I don't want to confuse people. Some of this stuff is extremely simple. Some of the stuff, the further that you dive into it, can get a little bit more complicated. So I sort of want to start off with force today. Ampere's force law equation is an equation that you can use to calculate the force between two wires carrying a current. Now, the analogy there between partnered output coils is the same analogy. Okay, so two wires, even though they're coiled up, they're still two wires. They both carry a current when they're set up properly, and normally the currents would oppose each other. For those people that set it up right, they would oppose each other. The magnetic fields also oppose each other. So the analogy is the same no matter what. Now, Ampere's force law can end up with a positive result or a negative result. The positive result means that the current is flowing both in the same directions, so it's an additive magnetic field force. A negative result is when the magnetic field is in opposition. The currents are in opposition, one flowing one way, one flowing the opposite way. So we have opposition, okay, and that's a negative result. So if you end up with say 1 Newton per kilogram of force, which is a fairly large magnetic field, then that figure, if it was negative, so -1 Newton per kilogram, then that would be opposing magnetic fields. Okay, same deal. Partnered output coils, same deal. Okay, so opposing magnetic fields, then you have a negative result. Same is true in a transformer. Okay, anyone that were to go through were to calculate using the right hand grip rule the current between the primary coil and the secondary coil, you would end up with a negative result, and obviously the magnetic fields would be opposing. Okay, now depending on who you speak to, you know, this can vary a little bit. Some people, some of the Numpty Club professionals will tell you that the magnetic fields are additive between the two coils. Totally and utterly wrong. Okay, use the right hand grip rule for conventional current, use the left hand grip rule for I don't know what you want to call it, current theory. Look into it, because the two things are different. Back in the 60s, I believe it was, science found out that current flows from negative to positive. So when I say conventional current, that's from positive to negative instead, because it's the old style. That's the style that everybody knows, everybody understands. We don't want to go through and confuse people and be silly about things. So I try to use conventional current. Everybody should already know that. And I do know that it is in the opposite direction. It's not rocket science, most everybody does know that, but I always try and say conventional current when I use conventional current. Anyway, Ampere's force law, okay, can be calculated very easily. Simple equation, it's not hard. Partnered output coils, they do oppose, so you will end up with a negative result, the same as a transformer. The MMF in the force law, okay, so N times I, which is the ampere turns, AT is the ampere turns, capital A, small t, is the basic equation. Okay, so if you have Ni or N times I, that is the ampere turns, which is also the MMF. MMF can be converted to Gilberts and Orsteds, I believe, off the top of my head. So we have force from any coil carrying a current, and when there's two, there's always a force between the two coils. forces must always be in opposition. Okay, partnered output coils, you've seen the image for so long now, it doesn't need to be pushed in your face anymore. The big red arrows in the middle show that the magnetic fields are in opposition to each other. The opposition is pretty straightforward, pretty easy to comprehend. Alright, so basically the situation is that when you have opposing magnetic fields, you pump current. Okay, now you separate voltage. The voltage is pushed. Okay, it's pushed via Ampere's force law from one terminal to the other terminal. Okay, now look up the Lorentz force, because that is also the same. Okay, there's a little bit of confusion there in science. We do have several things in science that pretty much sort of mean the same sort of thing. So the Lorentz force and Ampere's force law correlate very, very closely. There really is not much difference between the two. One is easier to probably follow than the other one because it uses diagrams, but basically the same thing. So anytime we have a voltage potential, okay, a voltage potential is, or you might hear the term a difference in potential, is a difference in potential from one terminal of the coil to the other terminal of the coil. So we might have 1 volt higher potential on this terminal over here than what we do on this terminal over here. So if we were to have 1 volt, then that would be 6.241557 or something like that, times 10 to the 18th electrons on this terminal more than what we would on this terminal over here. Okay, so that's voltage. Voltage is separated. Voltage is pushed from the copper atom. Okay, the copper atom has 29 electrons, and the electrons are all pushed down the end of the wire. Okay, that is a current. That is a current when that happens, when a load is connected to the ends of the coils. Okay, so if we were to connect a load to these two terminals, it would light, seen in the last videos. Now the electrons are what powers the load. Okay, the electrons have a charge, and again you need 6.241557, I think it is, times 10 to the 18th electrons is 1 volt. So if you have 20 volts, then you need to times that by 20. Okay, and if that same voltage is moving past a single terminal in 1 second, that's 1 ampere. That's where Ohm's law comes from. Okay, it's the amount of electrons multiplied by the rate of electrons. Okay, so power is volumetric. Power is volumetric. You can compare that directly to water flowing through a pipe. Okay, water flowing through a pipe is also volumetric. Okay, it's a volumetric quantity. So you have to multiply the rate of the water multiplied by the quantity of the water. It's volumetric. Okay. So I think today we're just going to leave this video reasonably short, but explain those few little things, because I did see a couple of comments about that. And remembering that a conductor, the charge can be separated on the conductor simply by moving a magnetic field at right angles to it. Okay, so that's where bucking coils come in. You can have huge power. Okay, you can have huge power from bucking coils if you do the right things. Okay, if you imagine in your head right now, if you imagine a 10 kilowatt generator. Okay, the 10 kilowatt generator needs often a petrol or a diesel engine to drive the generator shaft, basically to get the output power going. Okay, you load the generator down. Okay, you might put 5 kilowatts on it, and you can hear the motor on the generator slow down. Okay, it would normally kick in, and the revs would either go up a little bit or something like that, and then that would make up the difference in potential as the generator were to slow down. Now the same is not true when dealing with partnered output coils. Okay, I mentioned in my last video about antenna theory. Once you have a voltage potential, okay, once you have a difference in potential between the two wires here, then the current is pumped because the two partnered output coils buck each other. Now, I've seen wire where I've blown off probably 2 to 3 centimeters of wire because the current's been so high. So you need to be careful, okay? So don't be silly about this, you've got to be careful. But once you get your voltage potentials up, then current is pumped from source. Now we put water under pressure, okay? We put water under pressure to pump it through a pipe. We do the same with electrons. Remember, the copper atom has 29 electrons. We put those electrons under pressure. That is, the pressure is bucking magnetic fields, okay, partnered output coils. We put the electrons under pressure to push them down the end of the wire. Now theoretically, if your magnetic fields were high enough, you'd be able to dissolve that piece of copper that you can see there in an instant if your magnetic fields were powerful enough. Okay, it would just evaporate into fresh air. So you do need to be a bit careful, but think about this because it's really simple. It's not hard. Okay, the magnetic railgun. There's a couple of young fellas on YouTube that have built a small, very small magnetic railgun out of some magnets. Okay, they've got some ceramic magnets on one set on one side, one set on another side. They put a small, I think it's a round or square neodymium magnet through the middle, and all they do is they just push it to the start. Okay, virtually no force required. Okay, they just push it to the start and then they let it go, and when they let it go, it fires the magnet out the end of the railgun. Now the same analogy is true with electrons. Electrons have a charge, therefore they have to have a magnetic moment. So that means any external magnetic field makes the electron susceptible to movement depending on how strong the magnetic field is. So bucking coils pump current. The higher the pressure, the more electrons are freed from the atom. The more electrons freed from the atom, the more current that's available at the terminals. Okay, it's a really simple, basic, straightforward concept. Again, power is volumetric. Okay, so get your voltages up, but don't go too high because this is really dangerous. Okay, so whatever you do, you look after yourself, look after your equipment. Don't push this to any sort of crazy limit because you'll be surprised. Once you get to the point where it works, it'll work and it'll work really well. So don't blow everything to smithereens. People, I just want to say that because I saw some fantastic comments on YouTube today. When I was reading them this morning, I thought, wow, that's really good to see. So I want to thank those people. There's a lot of people that are coming out and, you know, saying about the trolls and stuff that we've had, you know, the amount of trolls and what the trolls have been saying and doing and stuff like that. I, just so that you know, I actually quite enjoy letting the trolls put their foot in their mouth. It's really funny to see how badly some of them behave. Like they try, some of them, well most of them, I think their first tactic is to be extremely nice, you know, extremely polite, extremely nice to you, and try and get you on side and try and, you know, buddy you up to the best of their ability and get the information that they want out of you. Okay, and that's their first tactic. I know very well how they work. I've seen it for a long time. So it's quite funny. watch for it, because some of the trolls, and most of the trolls, are people that we've already banned from the forum. If you watch some of their names, some of those names pop up all the time. Others will go and sign up a new account every 5 minutes, so others are going under different names all the time. So it's quite funny to watch. And they're really not smart. They're really not smart. So do your homework, people. What I've given you today is a little bit more information. Study up on antenna theory. Antenna theory can be a little bit complex for some people that don't really know much about it. But think length of wire, think waveform, think half wave and quarter wave. Okay, there's a difference between half wave and quarter wave. Study the half wave antenna first, because it's easier. The half wave antenna is quite important. That's an area that you can focus on to get your voltages up to a certain level, easily, cheaply, efficiently. It's a really simple process. So your input coil, you've heard the term exciting coil before. So your input coil really just excites your partnered output coils up to a certain voltage, and then once you have that certain voltage, then your partnered output coils do all the rest of the work. Okay, so again, what we covered before, the force in the machine is between partnered output coil 1 and partnered output coil 2. Okay, your input really doesn't see any force at all. Okay, all the force in the equation that I gave you is left over. 1 plus -1 plus 1 equals 1. So that's leftover force, and that's where your input coil doesn't see any negative forces. If anything, it sees a positive force. So once you get these machines running right, you will see your input actually drop right down. Okay, drop right down. So look for that, something to look for. Alright everybody, best wishes, look after yourself, look after your loved ones, look after those close to you, join the movement. This is really simple, you can do it. Okay, you can do it. Join the movement and let's make this world what it's supposed to be. Free and independent. Best wishes everyone.